So I said I was going to do a weekly litmus question, but it's taken me a little longer to get around to responding and posting the correct answer. If you guys remember, it's been almost a month now, I posted a question video asking why is it typically warmer at lower elevations and cooler at high elevations. Freaking freezing! And I asked you guys to respond, just sort of off the top of your heads to see what people know. So I want to thank all the people who posted responses, and I will be posting another question soon. But first, I wanted to show you bits of the responses that I got, and then come back with the actual answer. So here we go.
You know, I think I understand why scientists are sometimes called kind of nerds.
Nerds?
I think sometimes they just are misinformed.
Hey, I've been in school for 21 years getting informed. Getting informed and avoiding the real world, actually.
You know, when you're at your lowest elevation, things are kind of cool, you know? And you're at a pretty low elevation at that point. However, as you start increasing elevation, things are getting hotter and hotter. So that by the time you kind of reach maximum elevation, things are pretty hot.
I think you're answering a different question. That might be posted in a slightly different section on the Litmus magazine. I'll get back to you on that one, though.
I would expect that the, like, it's really hot at the Earth's core, so I would expect that, like, as you go further, and the heat on the ground can heat up the air above it, so, like, I guess I would assume that the places that are lower elevations that are closer to the Earth's core would be warmer in turn because of how close they are to the Earth's core.
Wait. Let me get this straight. You're telling me that it's really hot at the core of the Earth? I'm in Chicago right now, and it's been freezing, and my heat stopped working, so I could just shovel my way down there, bring up a little heat, have a nice little bath, warm up. Is that what you're telling me?
Well, my guess would be, and this is pretty much all I can do is guess on this, my guess would be because the air pressure is not as high up there.
Ding!
So when the heat comes down from the sun, it just kind of slips through it, comes down to the bottom where we are, where the pressure is higher because there's more activity and the ocean is tossing it around and you got all the cars and everything. There's a lot more activity, so it kind of keeps the heat within this altitude, within this area generally.
So when I originally posted this question, I used Denver as my high elevation example of a place that's a little cooler, and Phoenix as my low elevation place. Very important to the next answer.
Why is it warmer in Arizona than it is up there in Colorado, around Denver? Got it. Took a long time to figure it out, but I got it now. Right, okay. Arizona, Nevada, that kind of area. Area 51, spaceships, radiation. That's why. Radiation. And some nuclear testing from the 50s or whenever.
Yeah, FBI? Yeah, it's me again. Yeah, I think I got another one for you. Yeah, he sent me a video. He mentioned it, so I think he knows. So yeah. So that was a great answer. I don't think it's quite right because Area 51, it's all bogus. The answer to this question revolves around the complicated relationships between pressure, density, and temperature. And if you guys remember back, way back, in high school, you learned something about the ideal gas law. That equation is that P times V equals N times R times T, where P is pressure, gas pressure, V is the volume of the gas, the N is the number of molecules in the unit of the gas, R is the ideal gas constant, and T is temperature. So there's a relationship between the air pressure and the temperature. And not surprisingly, there's also a relationship between air pressure and elevation. The air pressure that you're experiencing is simply equal to the weight of the column of air above you. So if you're located at a higher elevation, that column of atmosphere above you is actually quite a bit shorter. And so the pressure that you're experiencing is less. So if the pressure is less, and that sits on one side of the equation, and temperature sits on the other side, obviously if everything else is equal, the temperature itself has to drop as well. This relationship between temperature and elevation is called the environmental lapse rate. And it describes this steady drop in temperature as you increase elevation. It turns out that the temperature drop is roughly 6 degrees Celsius for every kilometer you rise, which works out to be about 3.5 degrees Fahrenheit for every 1,000 feet. So there you have it. Now you know. I look forward to posting another question very soon, and hopefully it won't take me a month to post a response. I would again like to thank all of you who did post responses, and please encourage your friends to post when we have new questions. Thanks again. One last thing to note, if you want to read some interesting science articles, please check out www.litmuszine.com. You can find all sorts of cool things there, and they continue to post text items and hopefully more videos soon.